So I was pulling my hair out at this question, and this is my third attempt at it. And I think the problem is this actually supposed to be a T question because for these two, I can't actually um, get the lengths algebraically. It's possible for this one using an exponential substitution, I think, and that is similar to a question we did earlier. And I think when I did that question, it took like 15 minutes to integrate or something. So I really, 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 really think that this is supposed to be a T question. If I look here, yeah, see, doesn't say it, but I really think it should be because these two are impossible without a calculator. The only one that is maybe possible is the first one. Anyways, as I was saying, as you increase the power, the graph gets pushed into the corner, so it looks like the length goes to 2. So for the first one, let's call it L2. That'll be 0 to 1 root 1 plus 4x squared dx, which is roughly equal to, and I'll get that one now. And then for L6, it'll be 0 to 1 root 1 plus the derivative squared, so 6 squared, and then x5 squared. And then L10 is 0 to 1 root 1 plus 100 x power 9 squared 18. So let me numerically get that here. 0, 1 root 1 plus 4 x squared. So that first one is 1.48. And then the second one is calculating. Oh, I'm doing it on the Casio. It's much slower with the numerical. Might have to switch it to the software. Oh, here it is. 1.67. So as you see, as I suspected, it is getting pushed to 2, I think. So I'd imagine by the time you get to x power 10, we should get pretty close to 2. Should be really pushed right into the corner here, the graph. So we're approaching a length of 2. Now, before I go on, you can kind of see in general, the formula would look like this. 0, 1, root 1 plus, and n is the power. So the power came down and got squared, and then the power was reduced by 1 and then squared as well. That's 1.75, by the way. So you can see it's moving towards 2. I think we can make an approximation here. I think we can say that this is 0, 1. And I think if we were to change this a little bit, I think there's some rule that says root 1 plus a small number, which is what this would be, I guess. Well, the n could be quite large, actually. But no matter how large this is, this would be overwhelmingly smaller between 0 and 1 than the coefficient. So I still think we can take it as large. I think that's equal to roughly 1 plus epsilon over 2, I think. Or is it minus? Let me check. Root 1.01, yeah, is 1.0049, which is 1.005. Yeah, that's right. So as an approximation, you could say that this is roughly equal to 1 plus a half n squared x 2n minus 2 dx. So when you integrate that, that would be x plus a half n squared, increase the power by 1, divide by the new power between 0 and 1. So if you put 1 in, 1 plus a half n squared over 2n minus 1, and then put in 0, you get 0. So you're just left with this. Okay, let me clean that up a little bit. Multiply above and below by 2, so that's 1 plus n squared over 4n minus 2. I'm running out of space. Let me move this a bit. Or let me get rid of that there for a moment. Okay, so I'll just continue over here. Let me put that all together as 1. So that's 4n minus 2, 4n minus 2 plus n squared. Let me divide everything by n squared. So that n squared divided by n squared is 1, plus 4n divided by n squared is 4 over n, minus 2 over n squared, all over oh no, that trick isn't going to work here. So maybe my approximation isn't great here. Increase the power by 1, divide by the new power, put in 1 and put in 0. So it's just about putting in 1. So half n squared over 2n minus 1. Let me just see what you would get for the different values. So the first one was 1.67. So that's kind of close. Let's see what the next one would have been. What's that now? N is 6. So that's 6 squared over 2 times 6. No, so the approximation isn't great because it goes beyond 2 at this point. So is there any other way I can approximate this since I can't really do it algebraically? Let's think. Let's see. Well, I don't know. I don't know. Hmm. Hmm. I don't know. I think I am admit that we just have to keep it as a tech question, even though there's no T in it. But I'm trying to think, is there any kind of good approximation here? I don't think so. Already at 8 minutes for this one. Let me pause the tape. No, I'm gonna have to leave it at that. I can't think of any good approximation to get answers that close to this, except for this. But that only works well for the first one, and for the second one's it just is totally off. So yeah, I'm just going to open a ticket because I really think that this should say it's a T question. Yeah. Yeah, it has to be a T question.